Welcome back, everyone. Let's go ahead and go through some solutions for the Matplotlib exercise notebook questions. All right, here I am at the Matplotlib exercise questions. Let's go ahead and start with the first question, or the first major task, which was essentially creating data from an equation and then later plotting that out. So to do this, I first have to import NumPy as NP, and then there are many ways you could create this array of masses. And one way is just to say m is equal to NP linspace, and then go from 0 to 10, 11 evenly spaced. The other way to do that is with NP arrange. Really, tons of different ways you can do it, but at the end, you should get an array M that looks something like this, 0, 1, 2, 3, etc. And then the next thing we have to do is actually define the speed of light. So if we're defining it in meters per second, it's going to be c 3 times, and then we're going to multiply it by 10 to the power of 8. So 3 times 10 to the power 8 meters per second. We define that as the speed of light, which then means if we get an array E for these various masses, it's going to be the array mass times c squared. So E equals mc squared. You run that, and then you get this array, if we check it out, that looks like this. Okay, so we have 0, and then it eventually goes to some very large number. Part 2 is actually plotting this out. So to do this, we have to first import what we need from Matplotlib, which in this case is actually just pyplot as plt. And then we want to actually create E equals mc squared, and more or less we want to try to match it to what's shown here. So one really easy way to do this is with just a function call. So since we have just two arrays, we might as well just say plt.plot. You could also create a figure. Both ways are totally okay. But essentially what I just want to do is plot the mass at the x-axis and then energy at the y-axis. And in this case, the color looks to be red, and it looks to be like a thicker line, so we'll say line width, or LW, is equal to 5. And just running this, pretty much you can see we're starting to match up. So next things we want to do is add in a title. We'll say it's E equals mc squared, and then we'll add in an X label, which is mass in grams. Whoops. Add in the Y label, which is then going to be energy in joules. You can write out the full thing if you want. And once you run that, you'll notice that we're still ending a little beyond 0 and a little over 10. So I'm just going to set those limits. I'm going to say xlim from 0 to 10, and now I'm kind of matching up here. If you want, you could also set your y limits as well to start at 0. Kind of up to you. But at the end of the day, you pretty much have the same plot here. Now we could have also done this with a figure object instead of these plot commands. Really similar process. As you know, we just have to say fig is equal to plt.figure. We add a set of axes to this, so we'll say something like fig add axes at 0, 0, 1, 1, and then we just plot on top of that the mass versus the energy, and you end up starting to get a same plot. And as you may expect, you can start editing this as you see fit. So you can again say color is equal to red and so on until you get the same plot as we just did before. And then you can set underscore title, set underscore X label, etc. Either way is totally okay as long as you're able to plot out this relationship in the equation. So now let's go ahead and move on. We just did task 1 and task 2. There's part 3 to this, which is the bonus, and that's to see if you can figure out how to actually plot this out on a logarithmic scale. So the way we can do that is it's actually in the advanced concepts notebook or advanced commands notebook. We can essentially just grab the code here, I'm going to copy it, and then paste it in the cell here. And if we actually want a log scale, then if you Google search this, you can see that it's simply the command plt_scale log, and we'll show this in a logarithmic scale. And then if we want a grid, we can say plt grid, and it takes various parameters here, which major or minor. If you want to plot them both, you can say which both on both major and minor axes. And if I only want it on the y-axis, I can say y. And whoops, make sure we spell that correctly. We want to say which. There we go. Okay. So again, there's full explanations on Y-scale and PLT grid in the advanced commands Matplotlib. In general, we're not really going to be plotting anything so sophisticated, but you should be able to easily figure this out with a Google search or a Stack Overflow search or a documentation search. It's really critical that you have the comfortable skills in order to Google something or look something up instead of having to memorize every single command. All right, so the main things here is add in PLT Y-scale as well as PLT grid, and you have the various options, which you can always look up in the documentation. And as a quick note, if you're not doing it the functional way, you could have also just copied and pasted those lines after a figure call, and you would have seen the same effect. So these are also going to affect whatever figure the cell happens to be in for these commands. Now let's move on to the next major task, which was task 2, creating plots from data points. So we explained that there's essentially the yield curves that we want to plot out, and we gave you the information, so we're giving you the raw data. And this is probably more akin to what we're going to be doing throughout the rest of the course as far as plotting stuff. We're usually going to just actually have the raw data itself and then need to plot it out. So let's run this cell to make sure we've defined labels as well as July 16, 2007 rates and July 16, 2020 rates. And then what we want to do is plot them both here. Tons of different ways we can do this, but let's go ahead, and since I want 2 lines on the same plot, I'll use the figure method. I'll say fig is equal to PLT figure, and then I'm going to add a set of axes to this. So we'll say axes is equal to fig dot add axes, and then we say 0, 0, 1, 1. And so right now I have this blank set of axes, and I'm going to plot both July 16th, 2007 to it, as well as July 16th, 2020. And what was a little tricky here that maybe you had trouble figuring out is you could actually just pass in labels as your X to plot against. So we can say axes.plot labels versus July 16th, 2007, and then on the same set of axes call plot labels versus July 16th, 2020. So if you just run this, you can see we have the yield curves. However, I don't know which one is which means I need to add in a legend. So I can say here, label is equal to July 16th, and for the first one here, 2007. And then say label here for this one, July 16th, 2020. And then to make sure the actual legend shows up, I can say plt.legend. Run that, and I can see the legend show up as well. Notice here, if I say axes.legend, that will work the same. So you can either call legend off the axes itself or just the general command plt.legend. And if you want, you can add a semicolon to not see this output here of the legend. So that's our plot so far. And then the next task mentions that it looks a little strange that this legend is in the middle of the curves. So while it's not blocking anything, go ahead and move it so that it's outside of the plot. So how do we do that? Recall that we have the actual location. So I'm going to copy this and paste it in here. And essentially what this was hoping you would remember or look up is you have this LOC parameter, and we showed this, that you can actually then say, okay, if I put X more than 1, it will start outside of that figure canvas. And then I can say 0.5 to start kind of halfway here. So then when you run this, it went ahead and moved the actual legend. And again, we can say axes.legend or plt.legend. It should work either way. Next task is, while the plot above clearly shows that rates are changing from 2007, they dropped dramatically, to 2020, what it's not really showing is the relationship of the rates for the year between each other. So I can't really tell the difference between a 1-month yield and a 3-month yield for July 16, 2020. So what we want to do is then create a plot that looks like this, essentially plotting them separately. So obviously this is a good case for plt.subplots. How do we do this? First we say fig axes, since we know we're going to get a tuple returned. We say plt subplots, and in this case I want 2 rows, so we'll say n rows is equal to 2, and then the number of columns I want is just 1, since it's one plot right on top of another. And if I want, I can also edit the fig size. So the fig size was a little edited here to stretch it out just a little bit. And then what we're going to do is grab the first set of axes. So this axes object, if I just, let me comment this out so we can explore it. Recall axes is a NumPy array, and in this case it holds this top axis and then the bottom axis. So I want to plot on them. So here we'll say axes plot, and then I'm going to plot the exact same thing I plotted up here. So I can actually just copy and paste these commands essentially. And then I'm just going to overwrite them, but make one occur on 0 and the other occur on the second plot. So even just running this, you should now see these two plots. However, it's not really clear which is which. So I'm going to come back here and then set a title for each of these. So we'll say axis0 dot set title. And in fact, let's set the title to what this label would have been in the legend above. So I'm just going to copy and paste this or cut it out and set that as the title. And now let's delete that label. Since we're dealing with subplots, we don't really have an overall legend. Instead, we have a title for each of these. And then we're going to do the same thing here. I'm going to say axis1 dot plot. And in this case, let's grab this string code and match it up with the relevant plot, and then delete this label since we don't have a legend. And now since we run that, I can see here, whoops, this should have been set title, not plot. Sorry about that. There we go. And now I can see the corresponding titles. So here above, I can see the yield curve for July 16th, 2007, as well as the yield curve for July 16th, 2020. And note the differences here in behavior. Now I can clearly see 1 month versus 3 months versus 6 months are almost at the same rate. And then it's starting to grow as you get towards 5, 10, 20, etc. And here I can now see the differences between 1 month, 3 months, and 6 months. A little unclear how much of an extreme difference is actually happening when they're both plotted on the exact same set of axes. Then the final bonus challenge task was to try to recreate the plot below that uses twin axes. And eventually it would look like this. So for this, if you actually go and say File Open, and if we open up the additional Matplotlib commands notebook that we talked about before the exercise lecture, you would notice that if you start scrolling all the way down, and we do mention this in the very quick overview video that we do have instances of something like this kind of double set. So I would recommend that you simply just copy and paste this, and then edit it to your needs. So I'm going to copy this code, and then what we're going to do is edit it until it fits our needs, which is pretty much what we do all the time when we're trying to create something new. We're just going to copy what already exists and then edit it for our particular use case. And so you can see here that it looks like there's a plot, and then a label is set, and then for every something in 𝑦𝒂𝒕𝒊𝒂𝒔 labels, it looks like it's setting the color. So what's really clear here is what I need to do is change these plot calls so that they actually match with the data that I want. So what I'm going to do is simply come back up here, and I'm going to say plot labels July 16th, 2007, and then slip it here. So I have, whoops, there we go, plot labels July 16th, 2007, and then the other one is going to be labels July 16th, 2020. So we come back down here, and then we're going to swap out the data here. And then let's look at the next one. We actually know this command, set 𝑦Label. So looks like 𝑦Label here, it was having some LaTeX code so it could show m squared. That's what these $ mean. But in our case, we actually just need a simple string with the date itself. So it's going to be something like July 16th, 2007 for the 𝑦Label. And similarly for this one, we're going to say July 16th, 2020. And then for everything else, it looks like we don't really need to change anything. And we can see that it looks like the colors are matching everything up together. So now when we run this, you can see we get back essentially the same plots. And here is where we can actually begin to do things like edit the figure size. So if I come back up here to PLT subplots, if I want, I can say fig size is equal to something like 12:8 to start trying to match up to the original image here. You'll also notice that it looks like the spines themselves were colored as well as the text. And here we just have the text colored. Now, you can jump back here to the additional Matplotlib commands or Google search, and you'll notice that eventually we do discuss that you can set colors for different spines. And it looks like I want to set spines on left and right, so we can simply just copy and paste these commands. So we'll come back up here, and let's go ahead and set some spine colors. Notice that it's split between ax1 and ax2, where ax2 is this command, ax1 twin x. This is the key command to actually making it a twin axes. I'm going to paste this here, and let's go ahead and say ax1, ax1s, where spine left, that should probably be blue. So say set color blue on the left, and then I'm going to copy these same commands for ax spines right. But let's set the right one to be red so it matches up there. So say set that to red. And now when you run that, you should notice that you now have a blue left-hand set of axes and a red right-hand set of axes. And you can even experiment with the line width to just make it really clear, because right now it's technically right on top of that black line, so maybe it's not super visible, but as you make it thicker, you should be able to see blue versus red. Okay, and that's really all there is to it. You can then add things like setting titles or setting Y ticks, changing the font size. You can check out the full solution for that in the notebook, in the solutions notebook that is. But essentially, if you were able to figure out how to copy and paste the code from either a Stack Overflow post or from this post we had here on axes and twin axes, and then edit it to your needs, then you have the exact skill set we're looking for. Being able to take code that is being applied to a different situation, take it for your own situation, and then adjust what's necessary. Very common to have to do that for any task in Python. Okay, if you have any questions, feel free to post to the Q&A forums. I'll see you at the next section.